Hi guys, how are you doing? I hope that you are doing well. Today we talk about circular motion, which is section 1 and chapter 7. Here we have several things that we will talk about: tangential speed, centripetal acceleration, centripetal force, and describing what the rotating system. Our objective: solving problems about centripetal acceleration, solving problem about centripetal force. We'll explain how the apparent existence of an outward force in a circular motion can be explained as inertia resisting the centripetal force. First of all, let's introduce tangential speed. Tangential speed of an object in a circular motion is the object's speed along an imaginary line drawn tangent to the circular path. The tangential speed depends on the distance from the object to the center of the circular path. When the tangential speed is constant, the motion is described as uniform circular motion. In order to understand this, let's watch this simulation. In this simulation, guys, look, this is a car that is moving where in a centripetal or in a circular track.
A car moving in a circle.
This is called centripetal speed. Look, tangential speed, because if I here there is a tangent. Look, the speed is along the tangent of this point. Okay, here.
A car moving in a circular path experiences acceleration even when the speed at which it is traveling remains constant. This is because acceleration depends on velocity, and velocity is a vector with both magnitude and direction. When the car moves in a circle, the direction of the velocity vector is constantly changing. Therefore, the acceleration, or change in velocity over the change in time, is also changing. Acceleration of this nature is called a centripetal or center-seeking acceleration. When the radius decreases, the direction changes more quickly and the experienced acceleration is greater. When the radius increases, the direction changes more gradually and the experienced acceleration is not as noticeable.
Okay, guys. Now there is a question. You have to answer it based on the previous simulation. If the car is moving at constant speed, why there is an acceleration? Or why is there an acceleration? Okay, you have to answer this question on your notebook. After that, this is look, here we have an acceleration towards the acceleration here towards the center, and this is called tangential speed. And tangential speed depends on the distance between the center of circular motion to the object, and also depends on the mass. Centripetal acceleration: the acceleration of an object that is moving in a circular path and at constant speed is due to the change in direction. This is why there is an acceleration here, because even that the speed is constant, but there's a change in direction, so the velocity changes, right? So if the velocity changes, there is an acceleration. This is the formula. How can we find the centripetal acceleration? It's equivalent to tangential speed squared over the radius. As the particle moves from A to B, the direction of the particle's velocity, focus on this, particle's velocity here is different than here. Even the speed is constant, but the direction changes, so there is an acceleration. For short time interval, the change in velocity is directed towards the center of the circle. And look here, please. If I add this vector, which is v initial, to this vector, which is v final, like this, head to tail, the resultant or the difference between these speeds, or these velocities, the difference between them will be towards what, the center of the circle. This is why the acceleration will be towards the center. Centripetal acceleration always directed towards the center. You have seen centripetal acceleration as a result of change in direction, as what we explained before. In a circular motion, acceleration due to the change in speed is called tangential acceleration. Here, guys, now we will have two types of acceleration. Centripetal acceleration, which is a result of changing the direction of velocity. The second one is the tangential acceleration, which is a result of changing the speed, right? But the direction of velocity might be kept constant. To understand the difference between centripetal and tangential, consider a car traveling in a circular track. Because the car is moving in a circular circle, the car has centripetal component of acceleration. If the car's speed changes, also the car may have tangential component of acceleration. And here we will have two types of acceleration, tangential and centripetal. Centripetal force. You know, guys, if there is an acceleration, according to the Newton's second law, there is a resultant force, and this resultant force will be in the same direction of acceleration. If I consider a ball of mass m that is being whirled in an horizontal circular path of radius r at constant speed, the force exerted by the string has horizontal and vertical components. The vertical component is equal and opposite to the gravitational force. Thus, the horizontal component is the net force. Like this. Here, the force always towards what? The center. Here there is a force of the string which is called tension. Here we have a gravitational force. As you know, we have to resolve this horizontal component and vertical component. The force that is the force that keeps the object moving in a circular track, which is the horizontal component of the string, and the vertical component of this string, this part will balance what? The gravitational force. So there is no any vertical motion, there is only horizontal circular motion. According to the Newton's second law, we will have the following formula: F equals ma, F equals ma, where a is what? V squared over r.
Centripetal.